All right. Everyone, so today's lab, we're going to be doing, make sure to download a copy of the phase change activity. And what I'm going to be doing right now is just collect the data for you to be able to fill in the table in the bottom, and then for using that in order for you to graph. So on the back here, there's instructions on either using a graphing paper, using a program, or just graphing directly onto your notebook. So we'll collect some data right now. And what I have set up for us here in the kitchen, let me move the computer so you can see. We have our scale, some ice cubes, and then we have a timer, a thermometer, and over here I've set up our beaker with thermometer already in it. So the goal is to keep measuring. I'll try to control the fire so it's not too big of a fire, but in order for us to go through this experiment. Based on the procedure, we were supposed to record every 30 seconds. So as you're watching this video and you've graded your table on your own notebook, make sure to fill in the data table here every 30 seconds. So based on the direction says heat the beaker using medium-sized flame, start timing, record the temperature every 30 seconds. Right when you see that it's melted, I'll kind of help you with that part. And then it says write the portion when you see that it's boiling or bubbles are starting to form. And then continue to record the temperature for 2 minutes after the water starts boiling. All right, so let's see how far we can get through this process. Right now, though, I do want to measure how much ice that we're going to be using. So let's go over here. Technically, for this lab, we don't necessarily need this, but it's information or data that we can use for a further discussion when we do our practice problem. So I just have a cup here. I'm going to zero that. And let me move it closer so you guys can see the numbers. All right, so that's zeroed right now. And then I'm going to add our ice cubes slowly so I don't mess up our scale. On the lab procedure, I said about half there's not a specific amount. They just mentioned that half the amount, or about halfway through the size of your 400 milliliter beaker. So looking at our value, I'll read it out loud, but you can see in the video, it's 121.38 grams. So just keep that in mind. You can record it on this lab, but it's not something that will be calculated. It's something that we'll use for our demo. Okay, so now on this side, let me make sure our timer is activated. Okay, so I'll have our timer visible. And let me shift everything. The goal again is for us to be able to see the temperature, the fire, and the timer all at once, so you could record, and they'll point it out every 30 seconds. Okay. Now, I'm gonna first put our ice cube. Current room temperature is 21.5 degrees. So put our ice cube. Something to keep in mind, these are bigger cubes. So I'm gonna wait for the thermometer to like acclimate to the temperature. And as much as possible, I wanna get the thermometer to really touch the probe of or the ice to touch the probe of our thermometer. It's dipping down to about 2 degrees, and it's something that you have to consider given the condition that we have here. Again, we're dealing with ice cubes rather than crushed ice, and it's a lot of exposure to the air, not just, as if we had started where this thermometer is completely submerged in ice, then we would have a very different starting point. But here it looks like, before I turn on the fire, roughly about 1 degree Celsius. So we're going to use Celsius for our data. It's still dipping down, so maybe I'll wait until it gets to the point where and again, things to keep in mind. We are there's some errors that you could already point out. Things to to kind of improve on to the design of this lab, since we're using larger ice cubes, preferably smaller ones, crushed ice, or even if you could have the thermometer completely submerged in it or enveloped in it, then that you would get a better set of data. All right, it looks like it's settling down, so we should start this experiment. I'm gonna turn on our fire and start our timer. The key is to, let's see, left front. I'm just going to use low temperature here. Don't want to ruin our probe. All right. The temperature is already, we're a bit of a delay on our timer, but temperature is already increasing. And as we can see on the one side of your screen there, we can see that the ice is already starting to melt. So I'll call it the first 30 seconds. All right, looks like we have 5 degrees Celsius for the 30-second mark. More ice is melting. We're now at a minute, that's 6.9 degrees. I'm gonna stir the setup here. I need to make sure the beaker doesn't fall over. Really get as much of our ice submerged. We're at that minute 30, so that's 5.7 degrees. So a bit of a fluctuation there. So it's something to consider with your error, but we are plotting the graph looking for a pattern. Most of the ice, I would say about half the ice is melted now. For some reason, all right, for some reason our probe is causing an error. Give me 1 second. The thing with so we missed a couple of data points, but I'm gonna continue with our other digital thermometer. This time around, I'll just have to announce it. So it's at, let me see, a 3-minute mark. So we missed a couple of data points. It's 10.9 degrees. I have a feeling it overheated. And what I'll do is we have another backup thermometer, so we can always go back and forth. Because these digital thermometers is kind of the issue with them, is if they get too much heat from the surrounding air, they kind of malfunction. They'll work again later, but they need to cool down. All right, at 3 minutes 30, we have 13 degrees. 4 minutes, we have 17.2 degrees. I'm going to adjust our fire. And in fact, since we don't need this probe for right now, I'm going to move everything closer over here so you can see it better. The one thing about this experiment, I can't keep removing the thermometer. In fact, if I do that, something that you're going to have to keep in mind. It was, sorry, we missed one. It was 18 degrees at 4:30. The next one's coming up. All right, 19 degrees at 5 minutes. There's a little bit of ice, but maybe in the next mark here, we're gonna have it pretty much melted. All right, 5 minutes 30 is 18.1. So as you can see, there's still some fluctuation. Keep in mind, there is still a solid ice in our sample. All right, we are at the 6 minute mark and it's 23 degrees. There's only a few left of the ice cubes we had originally. So much of the phase change, the first step of the phase change had occurred. And during that step, we reviewed a while back, like what's happening to the intermolecular forces. It looks like the last piece of the ice cube, 6:30 mark, it's 28.6 degrees. So now we are dealing entirely with liquid now. And I need to be ready to switch the thermometer. This one's starting to overheat as well. Okay, I'm going to switch our thermometer. The next reading is 35 degrees. All right, next reading is 42 degrees. So as soon as we got to liquid, the temperature change is pretty drastic. All right, we're at the 8 minute mark, 50 degrees. This is now 8 minutes and 30 seconds. It's 60 degrees. It's getting really warm. 9 minutes, it's 65.7. Our next data point is 73.7. The first signs of the bubbles are forming, but not to the point where I'll call it as boiling yet, but all right, we're at the 10-minute mark. It's 80.6 degrees. Try to mix our water here. All right, that is, I'm going to switch thermometers, sorry. That reading is 91 degrees. So really getting close to the point where I see a lot more bubbles. I'm going to lower the temperature of the fire. I have 94.4 degrees now. So you can see bubbles are, more and more bubbles are forming. We're at 96.5 degrees. Almost there, 98.6. We're at the 12-minute mark. It's 99 degrees. Since it's been bubbling, the goal is to keep recording for a certain amount of time and see what data point we're going to get. It was suggested for a couple of minutes, but we'll see if we have to extend up to that point. We are at 100 degrees. It's looking like I'm going to have to switch thermometers again. The issue with these thermometers is they're overheat. One second, both of them are overheated. We did reach 100 degrees, so it looks like this next one, I don't know if I'll be able to measure a data point. Let's see. We missed one of our data points, but at least we can try this next mark. All right. Since both thermometers are out right now, we have reached 100 degrees. So at least we got to that point. It lingered around 99. I'm going to turn this off. Let's use all of the data that we got. At the beginning, there was a couple of gaps in time, but for the most part, the temperature held steady. So I'm going to stop this. Record all of your data on your data table. And there's some pre-lab questions, background information in the beginning here. It is also asking you to consider what is the theoretical melting and boiling point of water. So in degrees Celsius. And then at the end, it's going to ask you to do a percent error of what, based on our data and based on what you saw when it melted versus when it completely melted versus when it started to boil. It's asking you to do percent error comparing the actual temperature of boiling that we saw versus the theoretical, and do the same thing for melting. When everything completely melted, what was the temperature then versus the theoretical temperature of water when it melts, of pure water when it melts. Do this pre-lab data recording and answer the questions. You don't need to write the procedure on your lab notebook, at least for this one. At the very least, have a sketch of the setup that we have here, so that way there's a record of what the experiment looked like. All right, I'm gonna pause the video.